Hello students, welcome you back in the next lecture of Mathematics 1. I welcome you all after Diwali vacation. In the previous lecture, we have started with chapter number 5, that is ratio and proportion. But there was a long gap in between because of Diwali vacation. So let us take a quick review at whatever we have learned in this lesson. Okay, so let us start. Chapter number 4, ratio and proportion. As I have said, in this chapter we are going to learn about ratio, properties of ratios, operations on equal ratios, theorem of equal ratios, continued proportion and K method. All these topics we are going to cover in this chapter. Okay, then I explain you the meaning of ratio. That when we talk about two numbers, we write them in the form of ratio. As you can see here, 3:2 is same as 3 upon 2. That means when we compare two quantities with the help of division, it is called as what? Ratio. Then I told you that ratio is a reduced form here. So there is always a common multiple. Like here you can see that 3 upon 2 we can write as 3k upon 2k. That is, k is a common multiple here. Whenever the ratio is 3 upon 2, we cannot say that the first number is 3 and the second number is 2. It can be anything. Like here you can say here the one number is 12 and other is 8. So this is the ratio represents the reduced form. But always keep in mind that there is a common multiple. Then the concept of ratio we can extend further for the three numbers. As I can say, you can see here there are three numbers which are represented in the form of ratio. And same concept we can extend for the four numbers also. The four numbers also. So in this way we can write n numbers in the form of ratio. Okay. But here the word used is proportion. Okay. So instead of writing ratio, we use the word proportion. That means the concept it can be extended for proportion for more entities. Like we can extend it for n numbers also. Okay, so this you have to keep in mind that ratio is not limited to only two numbers. We can extend it. Afterwards, we have seen the concept of direct proportion or direct variation. There we took the example at distance covered by the car and the number of the number of liters of petrol required. And what we found out here that in direct proportion, the division is always constant. You have to keep this in mind that wherever there is a direct proportion, division is constant. And what more you will observe here is in case of direct proportion, if one quantity is increasing, second also is increasing. Like see here, 1 liter petrol and distance is 10 km. But the petrol, when it becomes 20 liters, the distance has become 200 kilometers. That means when one quantity is increasing, the other also increases. Such relationship is called as what? Direct proportion. And in direct proportion, division remains constant. This you have to keep in mind. Afterwards, we have seen the next, that is inverse proportion or inverse variation. What you have to keep in mind is in inverse variation or inverse proportion, multiplication remains the constant. That means product of the two quantities remains constant. In direct proportion, division remains constant, and in inverse proportion, product remains constant. And one more thing here to keep in mind is, in this case, when one quantity is increasing, the other is reducing. Okay, or if one is reducing, the other is increasing. Like you can see here, the speed is compared here. Okay, so when the speed is more, you know that the time taken is less. Okay, like here car and bullock cart is compared. That speed of car is 50 kilometers per hour and the time taken is 2 hours. The distance covered is 100 centimeters. But same thing if we think of bullock cart where the speed is very less, the time taken is more. Okay, so here as the speed is decreasing, time is increasing. So this is special about inverse proportion, that when one quantity increases, other quantity decreases and their product remains same. Okay, so this was about direct proportion and inverse proportion. Afterwards we have seen properties of ratios. Okay, so here the very first property is ratio is always written as A is to B. How you are going to read it? A is to B, where A is called as first term and B is called as second term. If the second term of the ratio is 100, then that particular ratio is called as percentage. The ratio remains unchanged if we multiply or divide both the terms of the ratio by a non-zero number. Okay, like you can say that A is to B is same as AK is to BK. That means we can multiply or divide by the same non-zero number to both the terms, first term as well as the second term, then the ratio remains the same. Then here, whenever we want to find the ratio, you have to take care that the quantities, they should be in the same unit. Okay, like if we want to compare the distance, then distance we can measure in many units like kilometers, meters. But when we try to compare two quantities, we have to see that their unit remains the same either in kilometers or in meters. Or you can see the example here. Here 2 kg and 300 grams. Here unit is kg and here it is grams. So we cannot write the ratio. It is wrong. We cannot write ratio here. We have to convert them to the same unit. Like this 2 kg we can write as 2000 grams. And then we can find out the ratio 2000 is to 300. That is 20 is to 3. Okay, so it is very much important that the ratio, when we want to find the ratio, the quantity should be in the same unit. Then here the ratio is always unitless. You can see here that when we divide here, when we convert into grams, that gram and gram is going to get cancelled. That means unit is not present here. So you have to keep this in mind. So these were all the properties of ratios. Now let us, after that we have seen the solved problems from the textbook. You also go through them once again so that you can understand it better. Okay. So all the solved problems from the textbook, nearly all I have discussed. Remaining you have to see by yourself. This question number 5 is not there. It is reduced. Afterwards we have started with practice set 4.1. And in that we have seen how to find the reduced form of the given ratio that we have seen. Okay, so I took some examples and some I gave for homework. I hope you must have completed the homework. Okay, in the second one also we found out the ratio, but here the units were given and then what we did is we converted them to the same unit and then we found the ratio. Like here, one quantity was in rupees and other was in rupees and paise. So we converted both the quantities to paise, that is same unit, and then we compared. We found the reduced form. Okay, so this is what we have seen in the property, that when there are different units, it is compulsory for us to convert them into same unit. Then and then only we can compare them. Then in the third question, we have seen about percentages. That I told you that when the second term is 100, it is called as percentage, and then we have seen how to reduce them to the lowest form. Okay, so here we have solved certain sums. Okay, then question number 4 was word problem, which is based on inverse variation, that we solved. Okay, then question number 5, where the ratios were given and we need to convert them into percentage. That means its second term should be 100. So we have to multiply or divide by a certain number so that the second quantity can be converted to 100 and we can express it in the form of percentage. And the second method I told you that if you want to convert the given ratio into percentage, simply you have to multiply by 100 and you are going to get the answer. Okay. So in this way we have solved the sums here. Then question number 6 was again the word problem which we have solved, which is based on ratio. Question number 7 and 8 from this practice set, they are cancelled. Please take a note of this, that these two questions are not there. So in this way we have completed up to this practice set 4.1. Now let us go further. Okay. So now we are going to see comparison of ratios. Here we are taking two ratios, and for that we require 4 numbers. So we are taking the numbers as A, B, C, D, and we are considering that these all numbers are positive. Okay, A, B, C, D are positive. So here these 4 numbers, when we write in the form of two ratios like A upon B and C upon D, in comparison of these two ratios, that is A upon B and C upon D, it can be done by using the given rules. What you have to do is, here you have to go for cross multiplication. Numerator of first ratio you are going to multiply by denominator of second ratio. We are going to find product here like this, and then numerator of second ratio and denominator of first ratio. This order you must follow, and then these products we can compare. Okay, and we can think that which ratio is greater or which ratio is smaller. So the very first rule is, after doing the cross multiplication we have to compare, as I have said, A into D, that means AD, and C into B, if we write it properly, that means BC. If AD is greater than BC, then the first ratio, that is A upon B, is greater than C upon D. Okay, this is first rule. Second rule, if AD is less than BC, then the second ratio is greater. A upon B is less than C upon D. That means the first ratio is less than the second ratio. And third rule is, if the product is equal, then we can say that both the ratios are equal. Okay. So these 3 rules are very important. All of you please write down these rules in your notebook. Okay. So write it fast. I hope you must have completed it. Let us go further. Let us see the solved examples from the textbook. Compare the following pairs of ratios. First one, 4 upon 9 and 7 upon 8. Okay. So as I have said, here to go for cross multiplication. Numerator of first ratio into denominator of second ratio. So 4 into 8. And on the other side, we have to go for numerator of second ratio into denominator of first ratio, that is 7 into 9. So 4 into 8 and 7 upon 9 we are comparing. So 4 into 8 is 32 and 7 into 9 is 63. You can observe that 63 is greater than 32 here, or 32 is less than 63. That is why the first ratio is smaller than the second ratio. Okay. So this way you are going to compare. Let us see one more solved example. Here the numbers are in square root. Root 13 upon root 8, root 7 upon root 5. Again same way you are going to go for cross multiplication. Root 13 into root 5, and on the other side root 8 into root 7. So here root 65 and here root 56. So they are under root, that means their order is same. So we can compare the radicands. You know the word now. 65 is greater than 56. Therefore, square root of 65 is greater than square root of 56. So here the first ratio is greater. Okay. Let us go further. Now let us start with practice set 4.2. Here the very first question is, using the property A upon B is equal to AK upon BK. As I have explained you in the properties of ratio, that we can multiply both the terms by the same non-zero number. So we have to use this property and we have to fill in the blanks. Here some blanks are provided to us. So I am solving first one. You will solve second one by yourself. Second one is homework for you. Okay. So let us take this. See here 4 ratios are given. So we will take each ratio separately. We will take first and second. Okay. So first ratio is 5/7 and second here 28 is given. So 28 I can write as 7 into 4. Okay. 28 I am writing as 7 into 4. That means if I am multiplying 7 by 4, I have to multiply 5 also by 4. Okay. So the ratio will be 28/28. Now take first and the third. Okay. So 5/7. This 35 I can write as 5 into 7. So if I am multiplying 5 by 7, I have to multiply 7 also by 7. So 5 into 7 upon 7 into 7. So the ratio will become 35/49. Then first and the last. See, here you have 3.5. You know that 7 5s are 35. But here point is there. So 7 here we are multiplying by 0.5. So if we are multiplying 7 by 0.5, we have to multiply 5 also by 0.5. So the answer will be 2.5 and 3.5. So in this way, all the 3 ratios here I found separately first. Then I will write it again as a final answer in the form of question. Okay, so see all the fill-ups here. In the first fill-up, here the answer is 20. In the second one, the answer is 49. And in the third one, the answer is 2.5. Please complete it. Okay, write it properly. Here you have to see that by what number we have to multiply both the places. Observe this number and find out that constant. You can see here the value of k here in the first ratio is 4. In the second one it is 7, which we call it as a common multiple. And in the third case it is 0.5. So this you need to find so that you can get the answer. Okay. So second one similarly you are going to solve. Okay. So let us go further now. Question number 2. Find the following ratios. Here also I am solving first 2. Then third and fourth you can solve by yourself. Okay. First one. The ratio of radius to circumference of the circle. And second one is the ratio of circumference of circle with radius r to its area. Now see, when I taught you the properties, I told that whenever we want to compare the ratios, their units should be same. But in case of circumference and area, the units are not same. Like if the radius is in centimeters, the circumference will come in centimeters, but the area will come in centimeters square. Okay. So this statement is not correct. I will give you the corrected statement. Okay, so we are discussing these both the questions. Third one, see the ratio of diagonal of square to its side. So the length of the side is given as 7 centimeters. So if side is 7 centimeters, you know that the diagonal is 7 root 2. You have studied this. If the side is x, then diagonal is x root 2. Similarly, if the side is 7, then the diagonal will be 7 root 2. And then you can find out the ratio. In fourth one, the length of the sides of the rectangles, that means L and B is given to you. So again here you have to find the ratio to the perimeter to the area. So here also perimeter and area, they are having different units. So what you should write here is find the ratio of the number associated with perimeter and area. Only number we are thinking about. We are not going to think about the unit, because as we have said, the unit must be same, but here the unit is different. So we are going to consider only the numbers associated with perimeter and area. Okay. So here you should write that find the ratio of the numbers associated with perimeter of area and area. Similarly here, the ratio of the numbers associated with circumference and area. Okay. So let us start with first one, the ratio of radius to circumference of a circle. So let us take the radius as r. Let the radius of the circle be r. If radius is r, then what is the circumference? You know the formula. Circumference of circle is 2 pi r. So you can write down the circumference, that the circumference is equal to 2 pi r. Now you want to find out the ratio. Ratio of the radius to the circumference of the circle. So write the ratio, r is to 2 pi r. So here you can see that r and r can be cancelled, and the ratio will be 1 is to 2 pi. Okay. And then write down the final answer, that the ratio is 1 is to 2 pi. Okay. Copy it down. Okay, let us go to the second question. As I have said, the corrected statement, the ratio of numbers denoting the circumference to the area of the circle. Okay, so here this word is important, or you can write down the word associated with the numbers. Okay, you have to only think of the numbers. Okay, numbers denoting or associated numbers. Any words you can use. Okay. So again here let us take the radius as r, which is given to us. So from that we can write down the circumference as 2 pi r and the area as pi r square. Okay. Circumference is 2 pi r and area is pi r square. Now we want to find the ratio of circumference to the area. So let us write down that the ratio is 2 pi r is to pi r square. You can see here pi and pi gets cancelled. Also one r gets cancelled, and therefore the ratio is 2 is to r. Complete it. And question number 3 and 4, as I have explained, you will solve by yourself. Okay, I hope you must have completed it. Let us go further towards the next question. That is question number 3. Compare the following pairs of ratios. Here 5 questions are given. Okay. So see, third question is very easy. Simply the numbers are given. So by doing cross multiplication you can compare them. So I am solving first and second, and remaining 3 you will solve by yourself. Okay. So let us start with first question. Root 5 upon 3 and 3 upon root 7. As we have seen in the rules that we have to go for cross multiplication here. Numerator of first ratio into denominator of second ratio, and numerator of second ratio into denominator of first ratio. So let us write down that cross multiplication here. See, root 5 into root 7, and here 3 into 3. But what you can observe here is root is present on left hand side and it is not present on right hand side. So while writing the product now, let us write it under root only. So root 5 into root 7 is what? Root 35. And 3 into 3 is 9, which we can express as root 81. Okay. So see, now both are having same order. So we can compare the radicands. I can say that root 35 is less than root 81. And therefore, the second ratio here is greater, or I can say that the first ratio is less than the second one. Okay, write it down. See, here comparison is not possible because I told you while teaching surds that we can compare the radicands only if the order of the surd is same. So here 3 into 3 9 we must express in the form of root. Then and then only we can compare it. Okay. So please remember that. Now let us move towards second question. Okay, so second question is 3 root 5 divided by 5 root 7 and the second ratio is root 63 divided by root 125. Now what you can observe here is that first ratio is in the form of simplest surds. But here they are not in the form of simplest surds. So let us convert these two. Let us see whether we can convert it to the simplest form. You have to see whether any perfect square exists here as a factor. So 63 we can write as 9 into 7, 9 is a perfect square, and 125 we can write as 25 into 5 where 25 is a perfect square. So by using that we can convert it to the simplest form as follows. Root 63 we can write as 3 root 7 and root 125 we can write as 5 root 5. Okay. Now compare both the sides here. If we compare both the sides, here also 3 upon 5 exists and here also 3 upon 5 exists. So we can remove that 3 upon 5. Okay, that means if we compare, 3 upon 5 can be removed from both the sides. And therefore we will be left with only root 5 upon root 7 and root 7 upon root 5. Now let us square it. So when we square it, we will get 5 upon 7 and 7 upon 5. Now it's very easy to compare this fraction. You can see that here the 5 upon 7 and 7 upon 5, if we try to compare, you can clearly see if you cross multiply. 5 5s are 25 and 7 7s are 49. So second ratio is greater. Okay. Orally you can multiply, or simply by observing you can say that 7 upon 5 is greater than 5 upon 7. Okay. So therefore here the second ratio is greater, and we can write down that 3 root 5 upon 3 root 7 is less than root 63 upon root 125. Okay, so this way we can compare the ratios. As I have said, these are simply the numbers. So cross multiplication will help you, and you can solve it by again converting to the simplest form as we have done here. Okay. Here also you can do by multiplication and you can compare. Okay. So copy this down. In the fifth one, you can observe and you can do it here. See 9.2 and 5.1. If you try to divide, you will get 1 point something as an answer. And here 3.4 is less than 7.1. So here you will get answer in the form of 0 point something. So simply by observing you can say that here this division is greater than 1 and this division is less than 1. So very clearly the first ratio is greater. That way also you can write. Or you can go for cross multiplication and you can compare. Okay. So this way you are going to solve. Now let us go further here. Question number 4. There are more sub questions. 1, 2, 3 and 4 are there, but 3 and 4 are cancelled. Only 1 and 2 are there for you to study. So from that, first one which is easier, that I am giving as homework. See what is first question. Quadrilateral ABCD is a parallelogram. The ratio of angle A and angle B in this parallelogram is 5:4. Hence, find the measure of angle B. Now here you need to use the properties of parallelogram. You know that the opposite angles of parallelogram are congruent and the adjacent angles, they are supplementary. That means sum of their measures is 180 degree. So here see angle A and angle B. they are adjacent angles, and adjacent angles, since they are the interior angle of two parallel lines, they are supplementary. That means their sum is 180 degrees. So you know their ratio, so you can take the common multiple as x, and you can write angle A as 5x and angle B as 4x, and then since they are supplementary, their sum is how much? 180. So you can write 5x plus 4x is equal to 180. From that you can get the value of x, and then you can get the value of angle B. Okay, so you can solve this as homework. I am solving question number 2, which is related to ages and little bit different. So let us go towards question number 2 here. The ratio of present ages of Albert and Salim is 5:9. 5 years hence, ratio of their ages will be 3:5. Find their ages. Now you know that in such questions we have to always write the first statement from the question itself. So when you write down the solution, always copy down the first question as it is. The ratio of present ages of Albert and Salim is 5:9. And whenever there is a ratio, we have to think of common multiple. So write down, let their common multiple be x, or let the common multiple of this ratio be x. So by using this, the present age of Albert we will get as 5x, 5 into x, correct? And present age of Salim we will get as 9x. So write down that. Therefore, the present age of Albert is 5x years and the present age of Salim is 9x years. Okay. So from the first statement, it was possible for us to write down these three statements. Always keep in mind that always write down the ratio, take its common multiple, and from that find the things in the form of x. Now make use of the condition 5 years hence means what? After 5 years. So we have to add 5 to both the places here. So 5 years hence Albert age will be what? 5x plus 5, and Salim's age is what? 9x plus 5. Okay, and the ratio is given. That means we have to write down it in the form of numerator and denominator. So write down according to given condition. Okay, so see, 5x plus 5, that is Albert's age, and 9x plus 5, that is Salim's age. We wrote in the form of ratio, and that ratio is given as 3:5. That means 3/5. So this we can write. Now we have to solve this. You know how to solve it. You have to go for cross multiplication. So this 5x into 5, that is going to give us 25x, and 5 into 5 is 25. Similarly here 9 7s are 27x, and 3 into 5 is 15. So your next step is ready. 25x plus 25 is equal to 27x plus 15. Now you have to go for change of side or equating the terms. Like terms you are taking together. So what we are going to do is this 25 we will shift to right hand side, and this 15 we will shift to left hand side. So the step is 25 minus 15 is equal to 27x minus 25x. So we are going to get 10 is equal to 2x. From that x is equal to 5. Okay. We got the value of 5, but don't stop here. See, we have to find present age of Albert and Salim. That means we have to find value of 5x and 9x. So get those values. Therefore 5x is equal to 5 into 5 25, and 9x is equal to 9 into 5 45. And the final answer as a statement. Therefore the present age of Albert is 25 years and that of Salim is 45 years. Write it down. Okay, so I hope you must have completed it. Now see, question number 3, 4 and 5. Sub question number 3, 4 and 5 from the fourth question is cancelled. Also question number 5, 6, 7 from this exercise is cancelled. So here we have completed with practice set 4.2. In a next lecture we will go further. We will learn more concept. Okay. Till that, stay home. Stay safe. Take care of yourself. Thank you, students.